This is the modern periodic table. 118 elements have been arranged in this table in a very systematic manner. There are some properties related to these elements which define the way in which these elements react. Since the elements are arranged in a very well-organized manner, therefore these properties also follow some particular trends. Let's see how. One important property of the elements is their atomic size. The size of an atom is also measured in terms of its radius, so it's known as the atomic radius. It is calculated as the distance between the center of the nucleus to the outermost shell. So this distance between the center of the nucleus to the outermost shell is known as the atomic radius of the atom. Sometimes atoms do not exist independently. They form molecules. In that case, we take the internuclear distance. That is the distance between the nucleus of the two atoms, and this distance is then halved. So this distance then gives us the atomic radius of one particular atom. At times, one molecule consists of more than two atoms. They can be 4, 5 or 6 atoms forming a molecule. Even in that case, we take 2 atoms at a time, calculate the internuclear distance, and half the internuclear distance is the atomic radius for the particular atom. So, in the periodic table, we see that oxygen rise right to nitrogen in the periodic table. What do you think? Is the size of oxygen atom bigger than nitrogen atom, smaller than nitrogen atom, or is it equal to nitrogen atom? Let's try to answer this. We know they are lying in the same period. What happens across a period? The elements are arranged in increasing order of atomic number. So going from left to right in a period, the atomic number increases. As the atomic number increases, we know atomic number is the number of protons. So the number of protons also increase. Nuclear charge. The nucleus consists of neutrons and protons. Neutrons are neutral, that is, they have no charge. So the charge of the nucleus depends on the charge of the protons. More the number of protons, more is the nuclear charge. Therefore, going from left to right in a period, as the number of protons increase, therefore the nuclear charge also increases. This leads to greater force of attraction on the outermost shell. The increased nuclear charge tends to pull the outermost shell closer to itself, and in doing so, the atomic size of the atom decreases. Let's see this pictorially. This is a particular period. The variation in the atomic size is true for all the periods in the periodic table. So when we move from left to right in a period, the number of shells remains the same because we know that the period number is equal to the number of shells. So if we talk of the second period, it has 2 shells. So as we move from left to right in a period, the number of protons is increasing, the nuclear charge increases. This tends to pull the outermost electrons or the outermost shell closer to itself, and in doing so, the atomic size decreases. Let's get back to our question. So is oxygen smaller, bigger or equal to the nitrogen atom? So we see that across a period, the atomic size decreases. So the size of oxygen is smaller than nitrogen. So oxygen atom is smaller than nitrogen atom. What do you think happens as we move from top to bottom in a group? Let's see. So when we are moving from top to bottom in any particular group, we know the atomic number increases because the elements are arranged in the increasing order of atomic number. As the atomic number increases, the number of protons increase, and therefore the nuclear charge also increases. We know in any group, as we move from top to bottom, the number of shells increase successively. They overweigh the increased nuclear charge. We know that the effect of increased nuclear charge is that it tends to pull the outermost shell close to itself. But as the number of shells is also increasing, they tend to increase the distance between the outermost shell and the nucleus. So one effect is of the number of shells. As the number of shells increase, the distance between the outermost shell and the nucleus is increasing. But the effect of increased nuclear charge is that it pulls the outermost shell. But this effect, the effect of the increased number of shells, overweighs the increased nuclear charge, and in effect, the atomic size increases due to the increase in number of shells. So when we move from top to bottom in a group, the number of shells increase, which overweigh the increased nuclear charge. So the nuclear charge also increases, but the distance between the outermost shell and the nucleus increases because of addition of a new shell in each case. In effect, the atomic size increases on moving from top to bottom in a group. So in the periodic table, whenever we move from left to right in a period due to increased nuclear charge and the number of shells remaining the same, the pull of the nucleus on the outermost shell increases. Therefore, they tend to pull it more towards the nucleus, and so the atomic size decreases. Moving from top to bottom in a group, the number of shells increase. Also, the nuclear charge increases, but the increased number of shells overweigh the increased nuclear charge, and in effect, the atomic size increases.